So students, now we're going to discuss about the characteristics of DC series motor. Uh, See, this any kind of DC motor characteristics are clearly defined. What is the relationship between torque and the speed? But we can able to clear the relationship of torque and speed through the torque and armature current as well as speed versus armature current. Then only we can clearly understand what is the relationship between torque and the speed. That is the main characteristics of uh, all the kind of DC motors, all the types of DC motors. Okay. Now we're going to discuss about characteristics of DC series motor. We know DC motors having a lot of types. Okay, for example, DC separately excited DC motor, self excited DC motor. Okay, again that self excited DC series motor, shunt motor, compound motor. Again, that compound motor having long shunt, short shunt. That long shunt, short shunts. Um, Deeply we are split up in cumulative and differential. Okay, out of this different types, we are focusing now characteristics of DC series motor only. First, we're going to discuss about what is the relationship between torque and armature current. Okay, the armature current is directly proportional to flux. We know the torque is directly proportional to armature current, so the flux is directly proportional to torque. The series field winding is carried the entire armature current in DC series motor. So the flux produced is proportional to the directly proportional to armature current. So torque also directly proportional to square of the armature current because armature and the field are connected in series. So the relationship is look like a parabolic curve in nature. In this graph, we are considering x-axis is armature current, y-axis torque. Whenever we are increasing that little bit amount of armature current, the torque is directly proportional to square of armature current. So in before the saturation point, its shape is look like parabolic. Next one is speed versus armature current. Uh, what is the relationship between speed and armature current? We can't directly relate any relations between speed and armature current. Through the flux, we can able to define the relationship between speed and armature current. Okay, the speed is inversely proportional to flux because the speed equations clearly explain speed is directly proportional to back EMF. Speed is inversely proportional to flux. The equation is V minus IA RA minus IA RSC divided by IA. Okay, the speed is indirectly proportional to armature current because armature current is directly proportional to flux in case of series motor. So the value of RA armature resistance and the series resistance, the effect is very small. So the speed is indirectly proportional to the armature current is mostly affected the speed. So the speed is inversely proportional to armature current. We can clearly understand through the graph. In x-axis, we are considered for armature current. Y-axis, we are considered for speed. Whenever the armature current will be increasing, the speed will be reduced because in starting stage, the armature current is very, very minimum. At that time, the speed is very high. Okay. Whenever gradually we are increasing the armature current, the speed will be decreased. So finally, we can conclude what is the relationship between speed and torque characteristics. Okay, the torque is directly proportional to square of armature current, or the speed is inversely proportional to armature current. So we can write speed is inversely proportional to square of torque because the torque increases depend upon the load. Okay, when the load increases, the speed decreases. We know whenever the load increases, the speed decreases. On no load condition, torque is very less. So the speed increases to dangerously high value. That only in DC series motor. So in this speed torque relationship of DC series motors is clearly defined. No load condition, the motor is not started because the speed is very much high value. So that much amount of high speed, the motor affected the windings. So it start to burn. Okay, that's only we put some amount of load, then only we are started the DC motor.